Hello everyone, welcome to my talk, Tools of Intentional Architectures. My name is Dinesh, I'm a software architect, and over the past several years, my focus is on engineering web applications in fintech space. In this talk, I will first spend a few minutes to quickly set context talking about accidental architectures and the importance of architecture-centric activities to drive the quality and success. And from there, I will talk about a few things from our toolbox that we can use to steer the architecture away from being an accident. I will not talk about programming languages, frameworks, patterns, technologies, etc. This talk is about work. One of the inspiration for this talk is Grady Wush's IEEE article on accidental architectures. In this article, he explains accidental architectures emerges from many individual design decisions during development, while intentional architectures are those that are explicitly identified and then implemented. In my experience, and many of you would agree here, that accidental architectures happen everywhere, and it is inevitable in a growing software. He also mentions accidental architectures are not necessarily evil, but they must manifest themselves through time. Let me reiterate my point here on accidental architecture with an illustration because this is very important. Architects and engineers get system requirements from different stakeholders at different point of time and deliver the required capabilities. They make a series of design decisions and end up in designs that deliver the capability incrementally. Some decisions are explicit, some just emerges over time during development. Often and over time, these decisions are driven by choice of programming languages, frameworks, platforms, best practices, and other non-technical organizational influences such as financial, political, legal influences, and even by the skill set. And we end up in a set of architecture decisions that emerge out of these circumstances. These emerged decisions doesn't always imply failure. The success or failure of these decisions is manifested based on the impact they have on the business value once they're delivered. And that impact could be a pure accident. That's why an architecture is often referred to as a bet on the success. And it is important that you do your best to know you are betting on a winner as opposed to waiting until most of the software is complete before knowing if the requirements are right or the design decisions are right or implications are right, so forth. When I say intentional architecture, I'm talking about making decisions with confidence and assurance that they will satisfy our stakeholder needs and drive success, despite the evolutionary nature and the influences on architecture. Here are the most common reasons why software fails: unrealistic and unarticulated project goals, inaccurate estimates of needed resources, unmanaged risks, use of immature technology, unhandled project complexity, and so on. This list is from IEEE magazine, published more than a decade ago. And in my experience, these are still the most common reasons why architecture fails. Intentional architectures can avoid almost all of this. If you take a closer look at this list, you will see that lack of functionality is not one of them. I came across a study on challenges in system assurances through Software Engineering Institute. Although the numbers are for safety critical systems, we can relate to any complex software system at a high level. The study shows that about 70% of the issues are introduced during the phases where you understand the needs of stakeholders, deciding what to design, and what decisions you make. 50% of the total project cost goes into rework after unit testing. The cost is much higher and not proportional if these issues are discovered later. At that point, your primary focus becomes affordability, time to market, and other pressures. This is where monorepo, trunk-based development, efficient CI/CD processes, etc., shine in moving the fault detection to left as much as possible. The takeaway here is not to bet on accidental success. It is very expensive to understand that you have an accidental architecture after most of the software is implemented. So far, we have looked at how a success or failure can just be an accident or circumstances. Lack of functionality is not the most common reason for software failures. How expensive it can get if you don't have confidence your software architecture will satisfy the business goals. Now, how can we be confident that we are focusing on correct requirements for the architecture and the architecture decisions we make will drive success? The answer to this is in repeatable, predictable, architecture-centric practices. Let's take some examples. When your organization or product sponsor or product owner um, talks about increasing market share, they may be thinking about making the product usable to the new market or modifying the existing product for the new market. If their intent is to maintain quality reputation, they may be thinking of highly available or highly performant products. And many such business goals, they think about modifiability or reusability in terms of the business goals themselves. These modifiability, usability, performance, etc., are often referred as ELTs or non-functional requirements in the industry. This is not new. You all know about this, and that's why you are here. These are the properties your architecture needs to satisfy your business goal, and they are derived directly from your business goals. When you design an architecture, you design to satisfy these properties. And when you are implementing your architecture, you are conforming to the architecture that satisfies these properties and thereby satisfying the business needs. In the remainder of this talk, we will review a few tools and techniques we can use across these two cycles to gain more confidence that our architecture will satisfy the business goal and it is intentional. Speaking of architecture-centric engineering activities, let's start with what drives the architecture. The requirements that have an influence on architecture decisions are said to be architecturally significant. Not all requirements are architecturally significant. We also call them architecture drivers, and they can be categorized under these broad categories. Design purpose, functional requirements, quality attributes, constraint, architectural concerns. Design purpose is to know why you are designing. Your rigor and detail in the design will be different if the purpose is for POC as opposed to you are designing for an estimation or production or just to do an audit. Architectural concerns are usually internal organizational requirements and issues that you need to consider when you design your architecture. They not necessarily drives the business outcome, but you need to consider them. And there's, of course, functional requirements, constraints. They are quite standard, you know about them. The quality attributes here are the utilities and non-functional requirements. These are so important, our entire conference is dedicated to this. Quality attributes has the most influence in your architecture, more than your functional requirements. Yet, they are hard to articulate them and often very expensive or not even possible to consider them later in the product lifecycle. If you don't consider them in the beginning after making decisions, no amount of clever coding will help you. We don't want to call it a non-functional requirement because it is a dysfunctional term that creates a false partitioning among the requirements. You cannot express a non-functional requirement with a functionality. It is used for, it is often used as a placeholder for everything assumed by different stakeholders. Just names alone are meaningless. They are vague, naive, and cannot be quantified. If you ask a room full of stakeholders what performance means to them, it is very likely each one will come up with a different answer, often leads to unproductive debates. These quality attributes are interrelated. One inhibits the other, one promotes the other, and are the key input to analyzing your architecture. In short, if you don't consider these, any architecture is fine. There are different approaches to make quality attributes a key part of the architecture activities. Here is a rough maturity model. Unstructured approach is at the lowest level, where the quality attributes are not known. Decisions rely heavily on how things were done in the past, or maybe for some other projects or by someone else, or blindly adopt some best practices that may or may not apply to your business context and hope for the best, resulting in nothing more than an accidental architecture. Then there are practices where you have some vague idea of the quality attribute requirement to guide you through the architecture, and you have evaluation processes periodically with the selected few key stakeholders where you all align with the assumptions, constraints, and organization level concerns, and so forth. It is still not sufficient to drive quality in your architecture. Formal methods or model-driven approaches can be considered an option but due to its limitations with the skill set in the market, the tools availability, and even the area is a very hard research area, it is not yet practical and common in typical web application development landscape. Scenario-driven approaches are considered mature when it comes to quality attributes. There are mature architecture activities that complements this approach. Let's take an example of what a scenario means. A vague performance requirement, initially expressed as "I want a fast website," is not useful to make a decision or evaluate whether a decision is right. But if you express this as a scenario with details around the production environment, the expected outcome, and a quantitative measure of the outcome, you understand the intent a little better. Here, the first scenario is a latency concern during normal operations. The second scenario adds a scalability concern to it. And the third is completely different and is a usability concern. These decisions you make for the decisions you make for the first scenario will be completely different than what you would do for the second or third. If you do not know or consider these details in your architecture activities, it would be an accident if your architecture satisfy or not satisfy these needs. With enough context set on the importance of quality attributes and scenario-driven approaches, let's look at some of the things you can do across the architecture lifecycle. In the remainder of the talk, we will look at each of these lifecycle activities and use a few tools that can steer your architecture away from being an accident. Let's start with the first activity, deciding what to design. With quality attributes being the influential and challenging architecture driver, let's look at how to tame it. One of the methods to get a good understanding of these quality attributes and its importance to our stakeholder is the quality attribute workshop. It is a method developed by Software Engineering Institute to characterize and prioritize the quality attribute scenarios needed by the stakeholder community. The workshop is quite prescriptive and guides you well. The key is to bring your stakeholder community together because there is no one else who can better describe their expectations. By describing, by bringing them together, you open a line of communication among them to understand what success means to them, what are the important business goals, how to characterize them, and is everyone on the same page. You will follow a few brainstorming techniques in the process to capture all the quality expectations that comes to mind in the form of raw scenarios. such as the scenario that I described just before for performance. You will then clarify and refine scenarios in a 6-part, a well-formed scenario to make sure that you have all the info you need to guide the downstream architecture activities and prioritize them either by voting or assigning business importance and implementation difficulty measures. The output of the workshop is a list of categorized, prioritized, well-formed scenario that you can use in other architecture activities to gain confidence. I highly recommend you use this method. Now that you have a prioritized, well-understood list of quality attribute scenarios, let's move on to the next activity, designing to satisfy these quality attributes. When you design your architecture, keep in mind if you need a top-down or a bottom-up approach. This influences how well you are able to achieve the intent of your design. In a top-down approach, you are not influenced by any technology or framework. Your design is abstract, and you decompose and assign responsibilities to components based on the properties that closely align with the business goal. In a bottom-up approach, you start off with concrete realizations like a framework or a predefined architecture pattern, and you need to find a way to satisfy the quality scenarios that you are designing for. You will need to mix these two approaches, but prefer top-down when you can. Designing an architecture is notoriously hard, and many processes and methodologies today does not give a guidance on this process. They just point you to a step that say do design with some details of input and output. Attribute-driven design is one method that will iteratively guide you through the top-down design process. The center of this process is the design activity. It guides you through the mapping exercise, bridging the top-down and bottom-up approaches using a hierarchy of design concepts, making this method a holistic approach to design the architecture. Design concepts here are your reference architectures, deployment patterns, tactics, externally developed components like frameworks, libraries, APIs, etc. The process is iterative and does not advocate reinventing the wheel. It provides enough information as to guide you how to decompose a component, which design concepts are applicable in which iteration, and so forth. Due to do use a design backlog to plan and track the different architecture drivers to make sure the higher priority quality attribute scenarios and constraints are addressed alongside the functionality. Create a quality attribute utility tree that gives you a big picture of all the important quality attribute scenarios, which you will prioritize for your design. The primary output of that design process are design decisions. In this activity, let's look at making the documentation simple and valuable. As you design your architecture, documentation plays a key role in communicating intentions to others, mainly to educate them or to negotiate with them or to get a buy-in. Use documentation to communicate how your decision satisfies an architecture driver you choose to address. Different stakeholders look for architecture for different purpose. An architect uses it to negotiate with it, compared to a maintainer who uses it to understand the ramification of his change. These are some of the golden rules for quality documentation. If your documentation needs you to explain it, then it had failed its purpose. Always write it with the reader in mind. Record rational, and if needed, provide information on the path not taken. Establish traceability so that it's well understood and it will have a good quality. With multiple use and audience of the documentation, one way to keep them alive across the architecture lifecycle is to use goal-driven approach. The important details you need to communicate in your documentation or design decisions, its intents and its consequences. As architects and engineers make design decisions, document they document these decisions as lightweight architecture decision records and store it in a register. We call them ADRs. These ADRs can be compiled into views based on the need at the point of time by a specific stakeholder. As these registers grow over time, um, at any point, if a stakeholder need to see an architecture view, you can compile these decisions into new views and store it in an architecture repository. And this cycle continues. So you have a prioritized list of architecture drivers. You did some design iterations and recorded some decisions and views. Now you need to answer one very important question. Do I have the right architecture? To be exact, will the designed solution have the properties to make my business successful? The evaluation process you follow should align with a few fundamental architecture evaluation principles. These principles, described by Felix Bachmann, are simple and practical for effective evaluation. First, you need an objective measure, a yardstick with which you can analyze your architecture. The yardstick here are your well-formed quality attribute scenarios that are derived directly from business goals. So understand the important quality attribute scenarios that you are evaluating in this process. The second set of principles are to understand the design being presented. Identify what components are relevant to the scenario that is being evaluated and what properties they exhibit and what side effects do they have. Finally, the analysis is a set of matchmaking process. The match between the evaluated scenario and the design decisions are analyzed as the evidences are presented. The side effects and the mismatches among the architecture properties and scenarios are recorded as architecture debts, trade-offs, risks, and so forth. Architecture trade-off analysis method, again from SEI, is a scenario-driven approach to evaluate architecture. It aligns to the fundamental evaluation principles and complements the scenario-driven approaches we need. The method itself is extensive, but it has the following benefits. It identifies risks early in the life cycle. It increases communication among the stakeholders. It clarifies all the quality attribute requirements during analysis. And it also improves the architecture decisions and documents by documenting the outputs, such as the risks, trade-offs, sensitivity points, and so forth. As you go through this method and identify consequences, record them in your areas to complete them. This will add value to the area. Once you have a confidence in your decision, how can you be sure that your implementation satisfies the architecture as designed? Formal automated design conformance is an interesting research area that had shown good progress in recent years. But there are several informal and manual activities you can do today to make sure the intent of the design is maintained when they are delivered. As your software grows, understand the distance between architecture and implementation so that you can take appropriate actions. TOGAF identifies different levels of conformance, and it is a good start. And other manual activities including educating your development team of the key decisions that you took in the architecture, their intent, and their consequences. Educate them on what aspects of architecture they cannot violate, and what aspects of the design they are free to explore. Guide them on achieving architecture integrity eventually as the architecture evolves. Establish and execute lightweight architecture compliance reviews and establish the process and guidelines. Leverage your static and dynamic analysis tool that you have today to protect architecturally significant code. Understand different levels of architecture conformance and automate as much as you can. Monitor design risks and architecture depths. Create an architecture dashboard that can summarize all this. Another set of information that that should come out of your evaluation process are the architecture depths. These are a bit different um, than what we usually call technical depth due to low code quality. They are violations of patterns, structural complexities, and architecture smells. Architecture depths has the highest cost of ownership. In most cases, they are intentional and shows issues with evolution. Due to the cost and its impact on other system properties, these depths are repaid only in large and long-lived projects. Know the activities and situation where debt is likely to be introduced. These are some of the causes grouped for better management. Some of these are expressed, some of these can be expressed as quality attribute scenarios and can be intentionally avoided. To manage the depth effectively, understand the 4 important points in the depth timeline. The time when depth is occurred, the time when you are aware of the depth, a tipping point in which your debt becomes a liability and beyond which it becomes expensive to manage, and the time when you can completely repay your debt. As you can see, this timeline, debts are not bad things until to a point where it actually delivers value. Effectively managing technical debts means becoming aware of the technical debt as and when they occur and intentionally taking the debt and repaying it before the tipping point. Eliciting debt and quantifying the impact is not a repeatable engineering process yet. There are things we can do here, meanwhile. Differentiate architecture depth and low code quality depth in your backlog. Associate it with the risk. Understand and make business indicators of the depth visible. Business indicators in the sense like increased amount of defects, slow rate of velocity, slow time to market, etc. These, what I just talked about, are not are by no means the only approaches out there. Most of these are from Software Engineering Institute, and I have provided enough references for you to go deeper in these methods. Regardless of the method, process, activity, or framework, language, patterns, regardless of any of those, if you do not understand and manage your quality attributes in your architecture, any failure or success of your architecture is just an accident to the circumstances. These methods steer your architecture away from being an accident towards activities that are repeatable, predictable, and they intentionally drive success of your organization. The references are here. I highly recommended you to take a look at them. With that, I thank everyone for listening, and I thank the organizers for this opportunity. Have a wonderful day.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.